This is where you, my targeted audience, is at. Across this river is the tip of the Cascadia subduction zone, Victoria, BC. It is the area in all of North America with the most tectonic movement. This is the Cascadian subduction zone. But what does this mean? To answer this, first we need to understand continental drift and how tectonic plates interact with each another. Over 200 million years ago, the Earth was different. On the other side of this ocean, there was nothing new, it was just more ocean. But perhaps what is the most interesting is that on the other side of North America, our landmasses used to be connected to Africa. On top of that, I could book a single Uber ride from here all the way to Antarctica without ever needing to cross over water. This is the supercontinent Pangaea. The continental plates of the Earth has been constantly moving for the existence of the world. It moves by almost 1 inch every year. If you times this number by 1,000,000, then times this by 200, and that is how we got from the supercontinent Pangaea to what we have here today. These motions take place on plates sliding around, the plates holding in a whole continent or an ocean. There's a few terms we must learn: a continental plate, convergent, divergent, and transforming boundaries.
A continental plate is where the plate is above sea levels, which makes them a lot thicker. At convergent boundaries, they collide and create thickness. They are much less denser than oceanic plates. They are less dense than oceanic plates due to the fact that they are made up of a different material, and they are around 165 pounds per square foot. It is mainly made up of granite. An oceanic plate is a plate underwater with very dense properties. A density of the oceanic plate is 200 pounds per square foot. They are formed from basalt rock, which is a kind of volcanic rock. It sinks down because of lower buoyancy. So a convergent boundary is a place where two tectonic plates collide. The thinner plate slides beneath the thicker one, and it would continuously to do so. It's also where two plates collide, which could cause earthquakes as well. And they can also form into volcanoes, and they could, because they form subduction zones. And they can also form mountains, such as the Himalayan mountain range. And as stated before, they could form volcanoes because they melt some crust, and develop a volcano in the continental plate, between these continental plates. And it can create many different types of rocks, such as metamorphic and sedimentary rocks. It gets subducted, creating a rock cycle, and it can also create underwater mountain ranges and volcanoes. Talking about many different convergent types, there are 3 types of convergence. You have the continental convergence, continental oceanic convergence, and finally oceanic convergence. Continental convergence is when two continental plates collide, and there is no magma release after the collision. Continental oceanic convergence is when an oceanic plate and a continental plate collide, and the oceanic plate goes below the continental plate due to density and buoyancy. It creates a subduction zone, and the magma leaks out from the pressure, which can create volcanoes. The final form of convergence is oceanic convergence. It's when two plates collide, and they could also cause magma to flow to the surface. The denser plate goes under the less dense oceanic plate, and it's the same, really similar concepts to oceanic continental convergence. Pressure releases the magma, which creates underwater volcanoes. Divergent plates are where there are two or more plates moving away from each other, from the mantle beneath the Earth. These currents in the mantles bring these plates away. Divergent plates split apart, and let the magma create a gap to let the molten magma out into the continental plates. Magma and mantle are very common underwater, which could possibly create underwater volcanoes. And also, these divergent plates created the Ring of Fire, which is a ring of underwater volcanoes under the Pacific Ocean. Transform boundaries are where two plates slide past each other, causing friction, which on larger scales also cause earthquakes. And they are slowly sliding against each other. It could form linear valleys, small ponds, deep trenches, and scarps and ridges, and these are basically examples of where transform plates have occurred. They could also form earthquakes. Transform boundaries could form earthquakes underwater as well, and could also form cracks in the ocean crust.
So now you know how boundaries work. To put them into perspective, I'll be using cloths to simulate how they move. At the beginning of this video, I spoke about Victoria, BC, the area at the tip of the Cascadian subduction zone. There are two tectonic plates in this area, the Juan de Fuca plate and the North American plate. These boundary plates are what is creating all of the earthquakes and ridges in the area.